In our last class we have started that the concept of hybridization, and due to some technical issue that the video I have stopped in between, and now here we'll be continuing from there upon. So where we have stopped the concept of hybridization. Okay, hybridization. What we discussed, what is hybridization? Hybridization is the intermixing of atomic orbital to produce hybrid equal number of and equal energetic orbitals. Okay, hybrid orbitals. We will be taking example and uh, we'll be taking example and looking into deep. Before that, I would like to tell you that one thing, that remember one thing. Hybridization, number of sigma bonds plus number of sigma bonds plus lone pair, number of lone pairs. Now here I am mentioning lone pairs, not electrons. Lone pair electron, only lone pairs. Here pair nothing but 2 electrons. Okay, pair is nothing but 2 electrons. So remember this carefully. So this is what very important topic is. I mean very important thing to remember, that most of the students they count the electrons. I said pair, lone pair nothing but 2 electron consist of one pair. Now you see here this is hybridization. So in any molecule, in any given organic molecule, we must have to identify in fraction of seconds in entrance exams. Like we are not writing here theory exams, but okay, here let us take one box. Before that I will be drawing one box. Okay, and then we will be going number of atomic orbitals, number of atomic orbitals, number of hybrid orbitals, number of hybrid orbitals. Just remember this. Okay, number of atomic orbitals, number of hybrid orbitals. Now you see here, if 1s plus 1p, if 1s orbital plus 1p orbital, if it mixes, what is that? Hybridization, intermixing of atomic orbitals. In which intermixing? That either sp or sp plus d or spdf. We are going to look at them one by one. Okay, one by one. See here, 1 plus 1 plus 1, how much? 2 sp orbitals are formed here. Okay, number of hybrid orbitals, how many number of hybrid orbitals forms? Only 2, because here 1s plus 1p. Now next 1s plus 2p, how much it should be forming? 3 sp2. 1 plus 2 how much? 1 plus 2 how much? 3 3s plus p2. Okay, plus p2, 3s p2. 1s plus 3p, 1s plus 3p. This is 1 plus 3, 4 sp3, 4 sp3. This is what? 4 sp3 was. Next 1s plus 3p plus d. 1d you can write 1d also, no problem with that. Now you see, yes, 1 plus 3, 4 plus 1, 5 sp3d, 5 sp3d. Now 1s plus 3p plus 2d. Now you see, 1s, 1 plus 3, 4 plus 2, 6 sp3 d2. So these are the hybridized orbitals are outcomes of the intermixing of two atomic orbitals. Two atomic orbital nothing but, for example, if S black element mixes with the P black element, S black element mixes with the 2p, here 2p nothing but here 1p. We will be taking example, no problem. For example, we will be taking one example, carbon. Okay, let us take let us take and let us understand this in clearly. But up to here, hoping you are understanding or you are following me here. Like now, you just note down this for quickly 1 minute. Prepare your notes, or else you will be forgetting this. Okay, or else you will be forgetting this in between. So now this is what number of atomic orbitals, intermixing and formation of number of hybrid orbitals. Now we'll see I am erasing this. Okay, I am erasing this. Now we see, we'll take example clearly and we understand. Now you see, Nana. Now you see here, if number of hybridization, if according to this, if now carbon, we'll see, take carbon. What is atomic number? Z of carbon is 6. Z of carbon is 6. Now we see, as we discussed in our previous video, okay, as we discussed 1s2, 2p2, okay, 1s2, 2s2, 2s2, 2p2, 2s2, 2p2. This is 6. 2 plus 2 plus 2, 6. Now you see here, these are the outermost orbitals or outer shell orbitals. Now we will be considering this. Okay, we will be considering this only. So this what we have seen is, this is S group, S black, and this is P black. Okay, P orbital. Okay, these are P orbital. Now this is what we discussed, ground state configuration. This is of ground state configuration. Now excited state configuration, we will be writing 1. This electron is migrated to the, see here, px, py and pz. Okay, px, py and pz. Now you see here. Now px, py and pz. Okay, this is excited state. This is excited state configuration. This is what? Excited state configuration. Now you see, one electron is migrated from 2s2 orbital to 2s shell to 2pz orbital. Okay, to 2pz orbital. Now we see, now this is free. Okay, we have drawn one graph also for better understanding. You please better watch previous class. Now you see here. Now when this is happening, now nothing but it is now in excited state. Nothing but most of the time it is unstable. Now to gain stability, it must have to go the hybridization concept to mix. What is it? Hybridization. To gain the stability, it must have to go under the concept of, under the phenomenon hybridization. What is hybridization? Intermixing of orbital. Now intermixing of orbitals, sir, this is only carbon orbitals. We need some other elements orbitals, right? Also, so here which element provides us one electron, will be taking them. Now you just see hydrogen. Since hydrogen has one electron, in outer shell, in its shell, it is donating here. If we bring, this is one electron, one electron. Now it is the formation of C plus H. H how many? 4. 1 C and H 4. This is what? Methane. This is what? methane. Methane. This is what is methane. Now, how many bonds it formed? 4 bonds. Its structure is this tetrahedral. See, H, 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 H. Okay, this structure is something looking like pyramid in this way. Okay, in this way. Now you see, this every bond is equal. Okay, every bond is equal. Before any ground state, it is not an equal, because energy levels of S 2s orbital and 2p 2 orbital is different. I mean, it is imbalanced, unequal. But when it merged with the hydrogen and yet in excited state, it is now, its orbitals are now in perfect equal energetic level. Okay, perfect equal energetic level. Now you see, this is, hope you understood this. Okay, tetrahedral, you can write tetrahedral. We will be discussing this in deep much. Okay, much we will be discussing, but for your understanding, this is what hybridization of methane is. Now we'll understand. Now we'll understand by taking some more examples. Okay, this will happen in every molecule. This is the only phenomena is happening. But now we'll see. Now we'll see. Now we see. Now, hope you understanding this, and now we take example CH3, CH3, CH2, CH3. Now, can you tell me hybridization of this? This is nothing but CH, H, H, okay, CH, okay, 2 CH, H. What is our concept? Number of sigma bonds. Count the number of sigma bonds first. Count number of sigma bonds. This carbon have how many sigma bonds attached to? 1, 2, 3, 4. 4 nothing but sp3 hybridization. Now this 1, 2, 3, 4 sp3 hybridization. 1, 2, 3, 4 sp3 hybridization. Now you remember. In any alkane chain of carbon without any electronegative atom other than carbon and hydrogen, it has only sp3 hybridization. Alkane nothing but these are alkane. Okay, you can say these are alkane. This nothing but carbon, H2, CH2. Here nothing but hydrogens are lying. Okay, above the plane and below the plane. Okay, we'll be discussing that, above, below the plane and this wedge form, those all in stereochemistry. We will be discussing them, but up to here you are understanding. Now comes the actual concept. Now you see here. Now you see CH3, CH2, O, ethyl alcohol. This is what ethyl alcohol. Now it is having lone pair. Oxygen is having how many lone pairs? 2 lone pairs. Now in this, can you calculate? Can you identify the hybridization? Now you see, as we know, this is sp3. This is also sp3. Now what about oxygen? Here what I have written? Number of sigma bonds plus number of lone pairs. How many sigma bonds here? 1, 2. 2 sigma bonds. Okay, sorry. For oxygen we are identifying, right? 1, 2. 2 sigma bonds plus 1, 3 and 4. Nothing but 4 is nothing but number 4. If we get in a hybrid mix, hybrid orbitals, what we will get? We'll be getting 4. 4 nothing but 3. Minus 1 we have to do, right? So that 3 nothing but sp3 hybridized. Hybridization. sp3 hybridization. Now, hoping that you are understanding. Now will you CH3, CH2, CH double bond, CH2. Now see. Now see for this compound. sp3. See, double bonds are there. sp2, sp2. How many this is one sigma bond and one is pi bond, so we are not considering pi bonds in the concept of hybridization. In counting in calculation of hybridization we are not counting pi bonds. I will tell you the story why we will be not counting that. Okay, why we should not count that also I will be telling you in further videos, but up to here don't count the pi bonds in calculation of hybridization. So this is now come CH3 CH2 double bond CHOH. Now you see here, now comes the concept. Now for your sake I am writing, this H like this. Now you see this is one bond. Now whenever, now see here this H2, okay, HCH2. Now you see here this is olefins nothing but alkene. Now you see here when there is a resonance nothing but in first video what we discussed, a movement of electrons inside the plane or outside the plane. When a resonant in structure, when lone pairs are in resonance, okay, this is resonance, okay, this is resonance. Now you see here this nothing but it will be getting positive charge, okay, it will be getting positive charge, okay, and then this is migrating here, okay, this is resonating form. You just understand this. I will be writing here OH positive, okay, positive. Next CH2 double bond CH single bond CH2 negative, okay, CH2 negative. Now you see again this bond, this negative charge is moving this side, this here, and again this is here, this is neutralizing. So this is what the hybrid the resonance is. These are resonating structure. These are what? Resonating. These are resonating structures. These are resonating structure. Now we see. Now let us take some. Whenever. Now can you tell me the hybridization of this oxygen? Now you see. Whenever the lone pairs are involved in resonance, you have to ignore them. Okay, see here, not both you are ignoring, but one you are counting and one is you are ignoring. Either this or this you are ignoring. Which pair is participating in resonance or involved in resonance, that you are ignoring, and the rest you are calculating. So that is what. So can you tell me now? 1, 2, 3. 3 nothing but sp2 hybridization. This is what? sp2 hybridization. This is what? sp2 hybridization. Now try for this. CH3 NH2. Now try for this. CH3 O minus. O minus, here I am writing minus. Minus nothing but extra. Okay, count that. Okay, CH2 double bond CH2 single bond NH2. Okay, calculate this for 1 minute. Calculate this. Now hoping that you are practicing this. Now you are practiced this. Now let us take some more example and understand. Let us take some more example, understand. Did you do this right? CH3, CH2, O minus, O minus, O minus nothing but what? O minus, extra electrons are there with it. Okay, extra electrons are there. Now we see minus, O minus, O minus how it forms. Okay, how it forms. CH3, CH2, OH, 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 CH3, OH. Now you see, this is acidic hydrogen. This is acidic. In reagents, you are knowing this. This is acidic hydrogen. When this oxygen loses this hydrogen, it gains. Okay. Whenever it loses this hydrogen, for example, you added with this methyl alcohol. Okay, methyl alcohol. You added HCl. Okay, you added what? HCl, acid. When you added this acid, H plus acidic, sorry, this is acidic hydrogen, right? We must have to add base. Okay, we must have to add base, not acid, base. Let us see base. When you added base, H2OH, nothing but NaOH, sodium hydroxide. When you added this, since this is electro, Na plus OH minus, Na plus, this OH minus will go and attack here and grasp that hydrogen. This hydrogen, now see, this hydrogen will go only by it. Whatever the hydrogen, whatever the electron that which it have, it will leave this electron here itself and then it goes. Okay, and there is a formation of CH3, CH2, O minus plus H2O. Simply water. Now we see here, when this happening, now what is hybridization of this? And now can you tell me, this is in excited state or this is in ground state? Okay, this is in excited state or ground state. Obviously this is in ground form and this is in excited state. Now it is waiting for some other reagent to attack on it, to satisfy itself. Okay, now you see, whenever minus charge is there, it is waiting for the plus charge. Okay, that we are looking that in reagents and reaction mechanism, intermediates and named reactions. There we are looking very deep, but here for your sake I am explaining you this. Now you see here. Now we see minus charge is there. Minus charge nothing but we must have to count it. So 1, 2 plus lone pair. Okay, plus lone pair. One lone pair is busy in negative charge. So what is 3 are there? 3 nothing but sp2 hybridization. sp2 hybridization. Now here sp3 hybridization converted into sp2 hybridization. Okay, sp3 converted into sp2 hybridization. If you know the concept of hybridization basically, and if wherever you go in acid base reactions, okay, and in stereochemistry, and you see, this hybridization concept helps you in interpreting the graph of HNMR, okay, and UV, IR. So their spectroscopy you will be feeling very easy if at all you are understanding this perfectly. If your GOC is very strong, then nothing but you will be excelling in spectroscopy also. And see, before learning named reaction, we must have to have basic concepts of GOC. If at all your GOC is strong, now you will be excelling. This is definitely what I can say is. Now we'll take some more example. Now can you tell me CH3, CH2, Cl. Now see, seventh group element. How many lone pairs of chlorine it has? You have to think by your own. You can think creatively. Now you see 1 2 3 4 sp3 hybridization. Now CH3 CH2 CBr, same. Bromine hybridization, same. Fluorine, chlorine, bromine, iodine, okay, arsenic, they all are seventh group elements. Seventh group elements nothing but they have three lone pairs surrounding of them, their radius. So here you see this also sp3 hybridization. Now comes the concept CH2. Try this your own. CH2 CHCl. Now CHCl. Now tell me hybridization of this chlorine. Now tell me hybridization of this chlorine. Now we know this is sp2, this is also sp2 sp3 sp2. Now chlorine hybridization. Now this is in resonating, okay, this is in when there is a lone pair, alternatively leave one bond, and if one bond is there here pi, okay, then this will be in resonance. Whenever a lone pair of electrons are involved in resonance, what we discussed, that we should be ignoring one pair and rest of the two pairs only we are counting. So 1 2 3 nothing but sp2. Okay, now this now whenever there is a resonance, if at all you are adding something, see, okay, we are not discussing that much in deep up at this level, but whenever we go forward, there we will be discussing very nicely. Okay, this is what, if p character increases, okay, if most of the time, so sp3 nothing but what, for example, sp3 nothing but what, so you have a bun, okay, whenever you have a bun, just imagine this is a cake. You divide into 4 parts, okay, you divide it into 4 parts. One part is s p p p. Now this p3 nothing but s is 25% and 75% 25%, okay, 25% nothing but 75% p and 25% s character. Okay, this s character, whenever s character is there, whenever s character is high, whenever s character is increases, then increase in the acidity, increase in the acidity. Whenever p character increases, increase in p character increases the basicity. Okay, this is very important. So that is what you are saying. Okay, hope that you are understanding this well. Okay, now for your sake that I am giving you some examples that you will be trying at your home and then come. Okay, and then come CH2 CH3 CO, okay, COCl, okay, COCl, nothing but this is what this structure you just imagine, it would be like this. Sorry, CH2, this is CH2 C double bond O Cl. Now you see, sir, you see what is the carbon of this? Two lone pairs are there, chlorine is there, okay, chlorine also there, okay, sp2 sp3 this is obviously, now you see, now you see here what could be it is. Now lone pair migration, okay, lone pair migration, okay, resonance, types of resonance we will be discussing, but here this will be sp2, this will be sp2 1 2 3, okay, and this now chlorine, oxygen, one lone pair, it is involved in resonance, so 1 2, so it is sp hybridization only, because since one pi bond is there here, okay, one pi bond sp hybridized, and this is sp2 hybridization chlorine. Okay, hope that you understood this and try these examples, and we'll be completing this NH 3. Okay, NH3, CH3, O minus 2. Okay, CH4, not CH3, O, Cl. Okay, now do this. CH3, COH, HCl. Okay, count this and do this. Okay, you can have so many your own examples. You can have your own examples. We'll be stopping this class today here, and one more video will be there, and that is very important. Okay, approximately I will be taking GOC approximately 7 to 8 classes. 7 to 8 classes in GOC we will be finishing, and tomorrow we are discussing hybridization, same but in overlapping, side by head to head overlap, and what is get structures of the orbitals. These are the concepts we will be discussing in next upcoming class, that is 4. Thank you for watching.